There are two different ways to classify triangles. The first way that you can classify them is through their angle measures. All right, and so you'll see up here that we have acute angles. All three angles in the triangle are acute, then you have an acute triangle. If you have one obtuse angle, it makes the triangle an obtuse triangle. You'll notice this third one has a little marking that indicates we have a 90-degree angle. So this is a right triangle. And then this last one has congruent marks. All three of the angles are congruent. And so this particular triangle is called equiangular triangle. So the first way you can classify your triangles is by their angle measure. And so if you just look at this first example, they want us to classify this triangle by the angles. So we're going to find triangle CDE, which is this one right here. And we're going to classify it. Well, for this one, they have this little mark down here. So CDE is a right triangle. It's a right triangle because it has a right angle mark there. Let's look at the next one. BCE. BCE. So we're going to find that one. Now this one has acute angles right here, but C is greater than 90 degrees. So it has one angle that is greater than 90 degrees. So that one is going to be obtuse triangle. And so this is how you classify them by angles. You find out what the angles are like inside the triangle, and you name it accordingly. So go ahead and do 3, 4, and 5. We have 3 different ways here. The first way is that all of the sides are congruent. You will notice the congruent marks here. 1, 2, 3, all of them are congruent. That makes it an equilateral triangle. All sides are congruent. The next one has 2 congruent sides. And by definition, it's actually at least 2 congruent sides. This is an isosceles triangle, at least 2 congruent sides. The last one has no sides that are congruent. No sides are congruent. This is a scalene triangle. And so if you look at this example, they want us to classify by the sides J, K, M. J, K, M. Well, JK is congruent to JN, KL is congruent to LN, but we don't see anything that makes those congruent to each other. So that particular one there is going to be a scalene triangle. If we look at the next one, KLN, which is this triangle right here. For this one, you see that we have KL congruent to LN. And so this one is going to be an isosceles triangle, 2 congruent sides there. The last one is JKN, which is this one right here. And for that one, you'll see 3 congruent marks on the 3 sides. So this one is equilateral. So when you're naming triangles, you actually need to name them both ways. You need to name them based on the angle measure and the side measure. So it's going to have 2 descriptions specifically telling about that particular triangle. So let's look at this first one. We have 2 congruent sides and a right angle. So we're going to name it 2 different ways. We're going to name it by the angle, which is right, and we're going to name it by the sides, which is isosceles. So this will be a right isosceles triangle. A right isosceles triangle. So go ahead and name the other 2 using both the angle and the side description. You can also have terminology that you have seen before that will help give insight into what's going on with the triangle. So in this case, they say PR bisects SRT. And so if I have SRT, the angle here, and they told me that PR bisects it, then that's how I know that these are congruent. If it bisects it and they told me this side is 30 degrees, then I automatically know that's 30 degrees. So I know those two are congruent if they use the term bisect for an angle. All right, so that helps me a little. I can say, well, since this is 30 degrees right here, and this one bisects this angle, then I know this one must be 30. So I know that these two are congruent because they told me that line bisects it, or that ray bisects it. They also told me U is the midpoint of RT. Well, here's RT. Here is U. If that's the midpoint, then I know that these two are congruent, and I know if this is 8, this is 8, because they told me that is the midpoint. And so sometimes they will show you in notation, and sometimes they will tell you in words what they're saying as far as congruence goes. And so once you have gotten the words and deciphered it onto the actual picture itself, you probably want to make your own notation. You probably want to make the notation that these two are congruent angles and that these two are congruent sides based on what they've told us. And so then they're asking specific types here. They're saying, well, based on that, UQR, what type of triangle is that? And so you're going to go and find the triangle UQR. And you're going to say, well, according to the angle measure, that's 120 degrees. So I know based on angle, it's going to be obtuse. And then based on the side measure, these two are congruent. So it's going to be isosceles. So this one would be an obtuse isosceles triangle. All right, and this is where colored pencils or highlighters are going to help you when you're taking a test or quiz for me. So the second one was RST, which is this big one right here. We have a 60 degree, a 60 degree, and we have 30, 30. Angle addition postulate tells us that is 60. So based on the angles, this is going to be equal angular. And then we have 16, 8 and 8. Well, that's 16. 8 and 8 is also 16. So this is also going to be equilateral. Just how they will always work out. Equiangular will always be equilateral. It says measure this, find the measures of the sides, then classify it by its sides. Okay? So they've given us 3 points on the coordinate plane. You don't have to draw it on a coordinate plane, but you do need the distance between the points because it wants the measure of the sides. Well, to find the measure of a side, you need to know the distance from one point to the other. And so that's exactly what we're going to do here. We're going to use the distance formula. And so you're going to set it up for the distance between the first one, JK, x1, x2, y1, x2, y2. And you're going to set that up using the distance formula. So we have -7 minus a -9 squared plus -7 minus 1 squared. And so for this one, we're going to get the square root of 68. Distance formula. Well, we have to find the distance between the next two, K and L. We're going to do exactly the same thing. Use the distance formula. Square root of 68. So then you've done J to K, K to L. You need J to L. So you need that third one. And we're going to do the same thing there. Distance formula. And so I have one side is, and you notice I didn't even simplify it. I didn't put it in decimal. I didn't try to reduce it out with a factor tree. You don't need to if you're just using it to classify a triangle, okay? So I have the square root of 68, the square root of 68, and the square root of 72. That tells me what about this triangle? What type of triangle is it? Not necessarily. But what do I know about two of the sides? Two of the sides are the same length, right? That means two of the sides are congruent, which tells me at least we're just classifying by sides here. What type of triangle is it? Isosceles. Isosceles triangle. So go ahead and do the next one and figure out what type of triangle you have. What type of triangle? Isosceles, scalene, or equilateral. Those are the three based on sides here. So two things can happen here when you have algebra. The first page here, they actually give you a triangle with some information. The second page, they're actually just going to use all descriptions. So this first one says ABC is an equilateral triangle. Solve for X and Y. And so if it's equilateral, then you automatically know what about the sides? They're all the same. And so they've given me 49 meters here. And then they've given me 3x plus 1, 18y minus 41. And so if I want to solve, I am going to set them equal to each other. So I will say 3x plus 1 equals 49. Subtract my 1 over. Divide by my 3. So I solved for x. That's part of it. They also want me to solve for y. So then I'll say, well, 18y minus 41 equals 49. Add my 41 over. Divide by my 18. Y equals 5. And so in the description, they can tell you something about the triangle, which will help you solve for your variables. So go ahead and try the next one. Another equilateral triangle. Find the measure of x and the measure of each side. Find the measure of x and the measure of each side. So for this one, they didn't tell us anything except that it was an equilateral triangle. We don't have a picture. Then they gave us 3. So you'll notice on this page they use equilateral, they use isosceles. Even if they don't give you a picture, you can draw one. And you can set it up exactly the same. So you can draw the picture if you need to. You don't necessarily have to. Because if they give you the side lengths, then you know just like on the other one, that all the sides are the same. And so you can pick any of the sides for an equilateral and set them equal to each other. And once you find one of the sides, then you will know the other. So when you solve for this one, you can subtract your 18 over, just like we did on the other one. Numbers to one side, variables to the other. So once you know that x equals 3 and it wants x and the measure of the sides, once again, you can plug it in and you will get all 3 of the side lengths with an equilateral. And so sometimes they can give you a picture, sometimes they can give you a description. Either way, you know based on the side length equilateral, they're all 3 congruent. Isosceles, 2 of them are congruent, okay? All right, the first theorem that we look at here is the triangle sum theorem. Triangle angle sum theorem. This theorem tells us that every single triangle has 3 angles that add up to 180 degrees. So all angles in a triangle will add up to 180 degrees, no matter the size of the triangle, no matter what type of triangle, equilateral, equiangular, they always add up to 180 degrees, which actually tells us a little bit something about an equiangular triangle. If we have an equiangular triangle and it always adds up to 180, what do we know about those angles?
360.
They're all 60 degrees, right? Because you have 3 of them that add up to 180. So in an equiangular, you automatically know the degree measure as well. Exterior. So this is a little bit different. So the interior angle is very easy to understand. Angle A, angle B, angle C, they add up to 180, okay? The exterior says that if you were to take one of the sides of the triangle, doesn't matter which side, and keep extending it out, you're going to create this exterior angle. So I have this exterior angle 1 here, okay? That measure will always equal the sum of the other 2. Not the one that it was supplementary to, not this one that it created a line with, but the other 2 angles will always add up to this exterior. So then if I were to draw a line extending this way and create this angle, it would always add up to these 2. And so anywhere on the triangle, you can extend one of your sides, creating an exterior angle. and it will add up to the sum of the other two. So in this case, the measure of angle 1 would equal the measure of angle 2 plus the measure of angle 3. Exterior angle theorem. So that helps us in finding, those two help us find different angles within triangles and on the outside. So look at these. They've given us 24 and 37. Well, I'm just going to say 180 minus the 24 plus the 37. And I'll get that angle 1 is 119. So this tells me, first of all, that I have an obtuse triangle, right? It also tells me that these two are not congruent. So when we talk about isosceles triangle a little bit more tomorrow, it also tells me a little bit more about the sides. So go ahead and do 2 and 3. So the other two are dealing with exterior angles. For this one, you had the 2 interior, you just had to add them up. For this one, you had the exterior and 1 interior, you sort of subtracted. They can get more complicated, you'll see as we go. So you may have to use something like this and work around the triangle. So if I look at this one, I have 2 out of 3 angles inside of a triangle. So if I'm going to try to find the measure of angle 1 here, I'm going to do what I did on that first one, 180 minus the 66 plus the 84. And that way I can solve for measure 1. So then if I know the angle of measure 1, there's a couple ways I can solve for 3. 3 would be the next easiest. 2 ways to solve for 3. 3 is an exterior angle, so I can either add the 66 and the 30, okay? Or it is linear to 84. So I can say 180 minus 84. All right, 180 minus 84. Either way, I will get 96 as my measure of angle 3. And so I know that this measure then is 96 degrees. And so then my last one that's to solve for is going to be my angle 2. So the measure of angle 2, I can take 180 minus the 96 plus the 43 to solve for that one. And so sometimes you can work around the triangle to get all of the angle measures based on what you know about that particular triangle. So go ahead and look at number 5 here. I have a right angle, 43 and 1. Angle addition, right? For this one, I can solve using supplementary if I want to. I have 12, and once I solve for that one, I can solve for the 3. So go ahead and try the measure of 1, 2, and 3 there. You can use triangle sum even if they don't give you any definite numbers for the angles. So in this case, all of the angles are given to you in algebraic form. We have angle Q is 4x minus 22, angle P is 10x minus 4, angle R is x plus 11. So even though we don't know what x is, we know that all 3 of those add up to 180, so that's how we're going to set it up. 4x minus 22 plus 10x minus 4 plus x plus 11. all equals 180. If I were subtracting from one of these, you would need to put the parentheses around them. But parentheses around them just has a 1 in front of it, so it actually doesn't change it, okay? But if I were doing any subtracting of a group, you would want to make sure you put the grouping signs around it so you don't forget that distribution. We're going to combine our like terms. So we are going to say 4x plus 10x plus 1x. And then we're going to say negative 22 minus 4 plus 11 equals 180. Add your 15 to both sides. Then divide by your 15. All right? And so that gave us the x value. To find the measure of the angles, you literally just plug it back in. So for the measure of angle P, I'm going to plug in a 13 here. 10 times my 13 minus my 4. To find my Q, 4 times 13 minus 22. And then to find my R, X, which is 13 plus 11. All right. For this next one, you would add these two and set it equal to that one, not equal to 180. So you would say 13x minus 11 plus 4x plus 1 equals 18x minus 15. All right, and so if it's an exterior angle, you're going to do it a little bit differently than you do the interior angles.